All right, next up, and finally, we have hit projectile motion, which is one of the first topics we learned, but it hasn't come up until the very end of this test. And so I'll just go over the basics. Projectile motion is when you shoot something into an air. You shoot it with an initial velocity v0, say, and then you shoot it with an angle of theta above the ground. Right away, the main idea here is to split this up into components. We can say, translate it over here. We can say it goes at an initial speed in the horizontal direction of v0 cosine theta because of the trigonometry, it's the cosine adjacent. And in the vertical direction, it goes v0 sine theta. Now, to v0 in the horizontal direction, to v0 sine theta, cosine theta, there is no acceleration. There is no external force changing the speed of the object in the x direction as it goes through the air. So this is constant. Now, v0 sine theta is the vertical speed, and we know that there is acceleration in the y direction, it's gravity, so which accelerates at negative 9.81 meters per second. And it's always 9.81 meters per second, no matter where on the trajectory you are. So the v0 sine theta part can be represented by the initial speed minus 9.81, which is a over 2 t squared. And I forgot to say, but since this is a constant velocity, the position would be v0 cosine theta times t. And then so we have these two equations, and then from here on we can pretty much do anything. We can solve for when y is equal to 0, y changes in velocity equals to 0, or the velocity is equal to 0, or when there's it hits the ground again, because we know it's twice the time it was to take to get to the top. And this is pretty much all we need. We separate the thing into components, and then we get these two equations. So yeah. Question 21 tells us that a cannonball is shot from the top of a hill like this, and its initial velocity is 25 meters per second, and that the angle it makes is 40 degrees. It also tells us that the hill is 30 meters high, but that this question doesn't really have any relevancy, so we can pretty much ignore that, and asks what the speed of the cannonball is at the top of its path. So the cannonball is going to make some sort of a path, a parabolic path like this, and at the top of its path, the y velocity is 0. We can see that it's not going up or down at the top of its path. It's pretty clear that the velocity in the y direction is indeed 0 because it's in equilibrium in the y direction. So therefore, the only speed of the cannonball is going to be the speed in the x direction, whatever this x whatever that magnitude of that velocity is going to be the speed at the top of its path. And now we know that initially it comes at an angle of 45 degrees. So if we split up this 25 meters per second into the vertical and horizontal components, we get that the vertical one is 25 sine of 40. And here we have 25 cosine of 40 is the initial velocity in the x direction. Now, as it goes upon this path, the forces that it encounters are gravity, which is a purely force in the y direction, meaning that it's not really changing the speed in the x direction. It's not accelerating or decelerating the ball in the x direction at all, meaning that this, for a 25 cosine 40 meters per second vector, as it starts with, it will continue with that same magnitude vector in the x direction the entire time because there are no forces acting upon it in the x direction, meaning that when you get to the top, it's still going to have that same speed in the x direction of 25 cosine 40. And when we plug in cosine 40 times 25, we get 19 meters per second, which is C.